Today we are discussing about Unix file system. In previous videos we are discussing about how file system works, how file system do formatting. We have discussed about two formatting, physical formatting and low level formatting and high level formatting. In Unix file system we are discussing about this is the structure of Unix file system, which is divided into two parts: file system area and user area. Very first block created on Unix file system is boot block, and the standard size of boot block is 512 bytes. Second block is super block, and the size of super block is 512 bytes. In file system area, the third block will be adjust for inode table. Inode table is resides in third block. Next, in user area, we have resides root directory table. Root directory table means the table which contains list of all files, file name and all other information about inode table. Now, inode table, there will be many entries. One entry is called one inode. Inode table always starts from third logical block. If one logical block is equal to two physical blocks, then second logical block will remain empty. One inode is there for every file. File name is not stored in inode. All the other information about the file would be stored in the inode. Unix keeps one table for some reason in user area, that is root directory table, also known as directory table. In this there are two types of attributes. You have clearly seen that file and inode. File 1 is stored on 5, inode number 5, and file 2 stored on inode number 4. So go to inode number 5 and you can retrieve the file, because all the information about F1 is there in inode number 7. Unix keeps the information about first 50 free blocks out of n free blocks in super block. Remaining free blocks are available in some other block in the user area. To store a file, you need two things: free inode, so as to store information about data file, so many number of blocks as per the size of the file. List of first 50 inodes is also stored in super block. Remaining list of free inodes you have to send through the inode table. The inode having 0 entry is available as a free inode. Unix keeps RDT in user area and not in file system area for some reason. Suppose a file is already stored, how to retrieve this file? Suppose I gave a command retrieve the file F1. Then what are the steps? To retrieve the file from hard disk, I need some information like track number, sector number, block number, which is stored in the corresponding inode of file. To go to this inode, I need inode which is stored in root directory table. But how to access RDT? There are two ways to access RDT. One way to store the address of RDT in super block, but normally it is not followed. And second way, I can regard this root directory table as a file. Then this should also have a inode number. This inode number is predefined. Inode number 2 is always used to store information of RDT. Now go to inode number 2. It is known that RDT inode number 2 get the address of RDT file and then access it for determining whether file F1 exists or not, and then access F1. All directories are treated as files. Steps for allocation: creation of a new file. Find out first 50 blocks. Find out first free block available. Make entry in RDT of file name and inode number. In inode number, make the entry, that is in inode table, at particular inode number, make the entry of block corresponding to the file and its details. Now, the whole information about Unix file system has been completed. Now we are switched to FAT file system. And in FAT file system, up to Windows XP, both file systems were supported FAT and NTFS, but from Windows Vista onwards, only NTFS is supported. The block size of boot block is 512 bytes. There are two copies of FAT file allocation table, that is FAT1 and FAT2, and a RDT. It is also divided into two parts: file system area and user area. All the operational things, that is boot block, FAT1, FAT2, root directory table, are resides in file system area, and user file area is free. Cluster is a term used to denote one logical block. In Unix Linux, logical block is called logical block only, whereas in Windows we call cluster. In Unix, logical block numbering starts from boot block, whereas in Windows it starts from user file area. FAT1 contains all information about n clusters which are in user file area. Each entry corresponding to one cluster or represents information about one cluster in the file system. In FAT1, you have clearly seen that there is a structure of FAT1. 1, 2, and are the cluster numbers, and 0, 0, 0, minus 1, 6, 8, 0, minus 1, minus 2 are the entries in the table. First cluster of F1 is 5. To find next, go to 5. 6 is the next cluster of file F1. Then for next cluster, go to entry 6. So it's 8. To find next cluster, go to 8. It contains minus 1. So 8 is the last cluster. First cluster of F2 is 4. To find next, go to 4. 4 contains minus 1. So 4 is the only cluster of F2. An entry 0 against a cluster means the cluster is free. FAT2 is copy of FAT1, just to avoid any loss of FAT1 or corruption of FAT1. Information about bad blocks. Let's take entry minus 2 to indicate bad block. Size of one FAT entry in terms of bit depends on the number of clusters. For example, if we want number of clusters to be 2 to the power 12, then size of one entry is equal to 12 bits. So for FAT16, it will be 2 to the power 16 clusters, and FAT32, it will be 2 to the power 32 clusters. It indicates how many clusters that can be supported by the particular file system. So how many bytes you can support on hard disk is equal to 2 to the power 32 bytes. Minimum unit of allocation is one logical block. If one logical block equals to two physical blocks, then suppose fourth physical block is bad and 3 is not, then also that logical block will be considered as bad. This situation is same for both Unix and Windows. Thank you very much, and I hope this will help you.